Question 1. The frequency table shows the time taken for 100 people to travel to an event. We need to draw a frequency polygon to show this information. With a frequency polygon, we're plotting the midpoint against the frequency. So it's going to be 5, 14, 15, 16, 25, 23, 35, 29, 45, 12, and 55, 6. So we're just going to plot all of these. And then we're going to join them up with a ruler. We grab our ruler and we join them up. We don't join the first and the last ones up together. We just join the points we've made, and that is our frequency polygon. That is all we need to do. Question 2. Bradley gets the bus on Saturday and Sunday. The probability that Bradley's bus will be late on any day is 0.15. Bradley draws this probability tree diagram. The diagram is not correct. Write down 2 things wrong with the probability tree diagram. So the probability of being late is 0.15. The probability of not being late should be 0.85. The probabilities have to add up to a whole. So the probability of not late on Saturday should be 0.85. And then we can see the probability of being late should be 0.15. And not late should be 0.85. So we've got 2 written the wrong way round. So the probability of late on Sunday after late on Saturday, the top one, should be 0.15. Or these 2 probabilities are written the wrong way around. They've been switched around. Question 3. Matt wants to invest £8,000 for 3 years. He can choose between Bank A and Bank B. Which bank will give Matt the most interest after 3 years? You must show your working. So to add on 1.2% compound interest, so for Bank A, we're going to have £8,000. We're going to add on 1.2%. To add on 1.2%, we multiply by 1.012. That adds on 1.2% in one calculation. We're going to do it 3 times, so we can write cubed. And then we'll just type that into the calculator. And we get £8,291.47. And then the same for Bank B. This time we get 2% in the first year. To add on 2% in one calculation, we multiply by 1.02. Then 1% for the second year and the third year. So times 1.01 to add on 1%. And we'll do that one 2 times. So it's 8,000 times 1.02 times 1.01 squared. And we get £8,324 and 2 pence. So which is more? Bank B is more. So Bank B. So we need to write a conclusion, and we can just write Bank B. So Bank B gives the most interest after 3 years. The average daytime temperature of 10 days is recorded. A shop also records its ice cream sales for each of the 10 days. The scatter graph shows this information. What type of correlation does the scatter graph go? So as temperature increases, ice cream sales also increase. As one increases, the other increases. That's called a positive correlation. On the 11th day, the temperature was 12 degrees. Estimate the ice cream sales on the 11th day. So to use a scatter graph, we need to draw a line of best fit. So it's a line that goes through the points. We want it to best fit the points, roughly the same number of points on both sides. We want to minimize the distance from the points to the line. So on the 11th day, it's 12 degrees. So we go to 12 degrees. So it's two little boxes is 1 degree. So 12 degrees is here. Then we'll read off the graph. That's 100 and either 125, maybe 130. So £130. The shop's manager wants to use a scatter graph to predict the ice cream sales for a day with an average temperature of 2 degrees. Comment on the reliability of this prediction. So we can only predict within the range of values we've got. We don't know if the relationship is going to stay the same as it continues. So it's not reliable because it would only be reliable within the range of values. So it would not be reliable because 2 degrees is not within the range of values. Question 5. Find 5% of 3.8 times 10 to the power of 105. So this is an interesting question because if you type in 3.8 times 10 to the power of 105, the calculator might give you an error. So the number's actually too big for the calculator, but we can find 5% of 3.8. Either 5% times or 0.05 times 3.8 gives us 0.19. So 5% of 3.8 is 0.19. So we've got 0.19 times 10 to the power of 105. 10 to the power of 105 is just 105 tens times together. So if we take one of those tens, to write it in standard form, it needs to be between 1 and 10. So we can multiply it by a 10 to make it 1.9. And that just takes one of these tens away. So we've now got 104 tens times together. So we've got 1.9 times 10 to the power of 104. Question 6. Verity buys 12 bottles of apple juice for a total cost of £15. She sells 12 bottles, all 12 bottles, at £1.75 each. We need to work out her percentage profit. So how much money does she make? So she gets 12 times 1.75, which is £21. So her profit is 21 take away 15, which is £6. So for any percentage change or percentage profit, it's the change over the original times 100. So it's changed by 6. The profit is 6. The original amount of money was £15. So it's 6/15 times 100. And that is 40%. So it's 40% profit. Y squared times y to the power of a equals y to the power of 7. Find the value of a. When we multiply indices, we add the powers. So 2 plus a must equal 7. What does a have to be? A must be 5. And y to the power of 4 to the power of b equals y to the power of 12. Find the value of b. So when we've got a bracket, we times. So 4 times b equals 12. B must be 3. So y to the power of 4 cubed is the same as y to the power of 12. Question 8. Change a speed of 81 kilometers per hour to a speed in meters per second. So change it into meters per second. It's 81 kilometers in 1 hour per hour. So we can change kilometers into meters by timesing by 1,000. So it's 81,000 meters in 1 hour. If we can go 81,000 meters in an hour, we'd have to divide that by 60 to find how far we can go in a minute. So that's 1,350. So we can go 1,350 meters in each minute. And divide by 60 again. We can go 22.5 meters per second. Question 9, the diagram shows a pentagon, and we've got a missing angle. We need to know what angles in a pentagon add up to, and that's 540. You can see that if we split a pentagon into triangles, it is 3 triangles. It's the same as 3 triangles, or you could remember to find the angles of any sided shape. It's the number of sides take away 2 times 180. So it's got 5 sides. 5 take away 2 is 3. So it's 3 triangles, 3 180s, which is 540. So the angles have to add up to 540. So we're going to take away the ones we know. We've got 90, 98, 92, and 121. And then that will be our answer. (139 degrees). Question 10. Density. So density equals mass over volume. The density of orange cordial is 1.21 grams per centimeter cubed. The density of carbonated water is 1.01 grams per centimeter cubed. A drink with volume 280 centimeters cubed is made by mixing 1 part of orange cordial with 7 parts of carbonated water. Work out the density of the drink. So we want the total density. So to do that, we're going to want to work out the total mass over the total volume, which we know already. So the total volume is 280. So it's 1 part orange, 7 parts carbonated water. So it's a ratio 1 to 7. So there's 8 parts. 280 divided by 8 is 35. So it's going to be, well, 1 part is 35. 7 parts is 245. So that's the volume of the orange and the volume of the water. We want to know the mass of each of them. We already know total volume. We're interested in the mass now. So the mass of the orange. So mass, if we rearrange this formula, it will be density times volume. So the density of orange is 1.21. The volume, that was a 35 centimeters cubed. 1.21 times 35 is 42.35. That's the mass of the orange. The mass of the water, it's got a density of 1.01, a volume of 245. So mass times volume, no, mass equals density times volume, 247.45. So now we know everything we need to know. So the density is the total mass, which is 42.35 plus 247.45 over the total volume, 280. So it's answer plus 42.35. That's the total mass over the total volume. And we get 1.035. And it's a density, it's in grams per centimeter cubed. Question 11. There are 5 starters, 6 mains, and X desserts in a restaurant. Bradley says there are 130 ways of choosing a starter, main, and dessert. Could Riley be correct? So to find the number of combinations, we multiply. It'd be 5 times 6 times whatever, however many desserts there are. So it'd be 30x. Riley says that there's 130. So 30x would have to equal 130. And x is going to have to be a whole number. And it can't be 130 because 130 isn't a multiple of 30. If we divide by 30, 130 over 30, x would have to be 4.3 recurring. And we can't have 4.3 recurring desserts. So no, x has to be a whole number. Question 12. Holly records the heights in centimeters of some girls. She used her results to work out the information in this table. Draw a box plot for the information in the table. So for a box plot, we need the lowest height, which we've got. The median, the upper quartile, we need the lower quartile. So the lower quartile we can find by doing the upper quartile, take away the interquartile range, because the interquartile range is the distance between the lower quartile and the upper quartile. So 172, take away 19, 153. So the lower quartile is at 153. And we've got the lowest, we need the highest. So we can do the lowest plus the range will give us the highest. 138 plus 44 is 182. So now we're just going to draw the lines on. So 138 153, 165, 172, 182. We do a box around the quartiles, and we draw these lines out to the highest and lowest value. So that is our box plot. Question 13. We've got a circle theorems question. A, B, and C points on the circumference. DC is a tangent. A, B, and BC are equal. So we've got an isosceles triangle. And we've got angle BCE is 65 degrees. Find the sides of angle AOC. So we're looking for this angle here. We can use, whenever we've got a triangle inside a circle, we can use the alternate segment theorem. So the angle in the other segment, so 65 degrees, is on one side of the line BC. The angle in the other segment, on the other side, is 65 degrees as well. And then we can use our isosceles triangle, but I'll give the reason first. So BAEC equals 65 degrees because of the alternate segment theorem. Then we can use the isosceles triangle. So angles at the base of an isosceles triangle are equal. So ACB is also 65 degrees. Angles at the base of an isosceles triangle. Then we can find the missing one, angles in a triangle. So 65 and 65 is 130. 180 take away 130 is 50 degrees. So ABC is 50 degrees because angles in a triangle add to 180 degrees. And then finally, we can use the angle at the center is twice the angle at the circumference. So we've got 100 degrees. It's double the angle at the circumference. So from the same points, in the same segment, the angle at the center is double the angle at the circumference. There would have been an alternative way of doing this. So if you, let me clear this. So if we had started with tangent meets radius at 90 degrees, we could have said this one in here must be 25. Then we've got 25 here. And then what we've got is two congruent triangles. So two radiuses and BC, two radiuses and AB. So they're equal. So 25, 25. So this angle is 50. And again, the angle at the center is double the angle at the circumference. Question 14, make D the subject of this. So make it D equals. Let's get rid of the square root first. The opposite of square rooting is squaring. So E squared is D plus E over DE minus 2F. Then let's get rid of the fraction. So multiply both sides by DE minus 2F. So we've got E squared times D minus 2F equals D plus E. Expand the brackets. DE cubed minus 2E squared F. Just writing them in alphabetical order. Equals D plus E. So I've got two D terms. I want them on the same side, and I want everything else on the other side. So I'll plus 2E squared F to both sides. And take away D from both sides. Now I've got my two D terms on the same side. I don't want two D terms. I want to make them one. So the way we do that is by factorizing. We take D out. So there's just one D term. And it's D times E cubed minus 1. So now D times E cubed minus 1 is equal to that. To get D by itself, divide by E cubed minus 1. And D is now the subject of the formula. Question 15. Here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. So there are different methods for finding the nth term. If you use a different one to me, that's absolutely fine, as long as you can find the answer. So I found the first difference. The first difference is 7, 10, 13, 16. That's what it's going up in. And then the second difference is 3 each time. The second difference is always the same in a quadratic sequence. So the second difference is always the same. So I've remembered that this term here is 2a. The quadratic nth term is an squared plus bn plus c. The 3 is 2a. This term here, the difference between the first two terms, is 3a's plus a b. And the first term is always a plus b plus c. So we can use this to work out what a, b, and c are. If 2a is equal to 3, a must be 1.5. So a is 1.5. If 3a plus b is equal to 7, and a is 1.5, 3 1.5s are 4.5. So 4.5 plus b is 7. B must be 2.5. And if a plus b plus c is equal to -3, 1.5 plus 2.5 plus c is equal to -3. 4 plus c is -3. C is -7. So we've got 1.5n squared plus 2.5n minus 7. And that is the nth term. You can check your answer. So we have 1.5n squared plus 2.5n minus 7. And if I put 4 in, I should get 27 out. So when n is 4, the fourth term is 27. The fourth term is 27. And you can check that the first term is -3. And it is. So we know we've got the nth term right. The diagram shows a triangular prism. We've got C to D is 20, A to D is 30, FDC is 35. All that's shown on the diagram. Calculate the size of the angle the line AF makes. AF is this line here, with the plane ABCD. So the angle AF makes with the ground. Give your answer correct to 3 significant figures. So we are looking for this angle here. And we're going to use this right angle triangle that I've just drawn in order to work it out. So we can use the right angle triangle ADC first. This right angle triangle ADC. We know A to D is 30, D to C is 20. So we can find the hypotenuse. AC squared is 20 squared plus 30 squared. So Pythagoras' theorem, 20 squared plus 30 squared is 1,300. Square root the answer, 10 root 13. And we can just leave it as 10 square root 13. So that's AC, we know that. We can also work out CF, another side of our right angle triangle, using this right angle triangle here, which is DCF. We've got 35-degree angle. We've got 20 centimeters, and we want CF. So we've got the opposite and the adjacent. So it's tan. TOA. Tan with the angle is the opposite over the adjacent. So times both sides by 20. We've got 20 tan 35. And that is 14.0. We can even store that in the calculator if we want. Store as A. And now we've got two sides of our right angle triangle. We've got C to F as 14.0. We've got A to C as 10 square root 13. And we want to find angle FAC. So again, it's a right angle triangle. We've got the opposite and the adjacent again. So it's tan. So tan x is TOA, opposite over adjacent. And we're going to shift tan to find our answer. I'll do it in one step. So shift tan. Answer, which is 14.0 over 10 square root 13, which was A to C. Press equals, we get 21.2. So it is 21.2 degrees. Question 17. Prove algebraically that the sum of the squares of any two odd positive integers is always even. Sum of the squares, so any two odd numbers. So an odd number, we can say is 2n plus 1. We're going to square it, and we're going to add it onto another odd number. And let's call that 2m plus 1. So a different odd number. So 2 times any number plus 1 is odd. And then 2 times any number plus 1 is also odd. So we're just going to expand these brackets. So 2n plus 1 times 2n plus 1. And we're going to add it on to 2n plus 1 times 2m plus 1. So 2n times 2n is 4n squared. 2n times 1 is 2n. 1 times 2n is 2n. And 1 is 1. 2m times 2m is 4m squared. 2m times 1 is 2m. 1 times 2m is 2m. And 1 is 1. So if we collect the like terms, we've got 4n squared plus 4n plus 4m squared plus 4m plus 2. How can we prove it's even? So we can factorize 2 out of this. So 2 times 2n squared plus 2n plus 2m squared plus 2m plus 1. So it's a multiple of 2. Anything times 2 is a multiple of 2. And anything in the 2 times table is even. So it is even. Question 18. The functions f and g are such that f of x equals 3 over 6x plus 5. And g of x is x squared minus 2. Solve f g of x equals 1. So f g of x means we're putting the g function into the f function. So the whole of the g function, x squared minus 2, goes into the f function. So whichever one comes second goes into the one that comes first. So it's like having f of x squared minus 2. We're putting the whole of the g function into the f function. So that means we're changing x into x squared minus 2. So where we had x, we're writing x squared minus 2. And it's equal to 1. So we're going to find out what x is that makes this 1. So we're just going to solve the equation. Expand the bracket first. 6 times x squared is 6x squared. 6 times negative 2 is negative 12. And then collect the like terms. Negative 12 plus 5 is negative 7. Multiply both sides by 6x squared minus 7. We just want to get rid of that fraction. So we get 3 equals 6x squared minus 7. Because 1 times 6x squared minus 7 is 6x squared minus 7. Plus 7 to both sides. Divide by 6. So 10 over 6 is 5 over 3. I'll write it up here. So 5 over 3 is equal to x squared. So x is the square root of 5 over 3, which we could write 1.29, or we could leave it as in the third form, square root 15 over 3. Either one of those two answers, absolutely fine. Question 19. Show that the equation x to the power 4 minus 3x cubed minus 7 equals 0 can be written in the form x equals the fourth root of 3x cubed plus 7. So what has happened to change this first one into the second one? So we've plussed 3x cubed to both sides and plus 7 to both sides. And then to get rid of the power of 4, we do the fourth root. And that is rearranged. Starting with x0 as 3, use the iteration formula 3 times to find an estimate for a solution to the equation. So we're putting in 3 to get out our next answer. So we're putting in the number for x on the right side, and we get out the next one as our answer. So for x1, to get x1 out, we need to do the fourth root of 3 times 3 cubed plus 7. Substituting in 3 to get out our first answer. So I'm going to press 3 and equals. So I can just press the answer button. And then I want the fourth root. So the fourth root of 3 times my answer cubed plus 7. So the fourth root of 3 times 3 cubed plus 7. And I get out my first answer of 3.0628. Now I need to substitute this answer in. To find x2, I want to do the fourth root of 3 times 3.0628 cubed plus 7. So I'm substituting in my next answer, my previous answer, to get the next answer. But because I'm already using the answer button, I can just press equals again. 3.10705. And then again, I want 3 times 3.10705 cubed plus 7 this time. But again, I can just use my answer button, 3.13816. And that is my answer. Question 20. BAC is a sector of a circle, center A. AC is 12, so the radius is 12. So AB is also a radius, it's also 12. Find the area of the segment, of the shaded segment. So we've got the area of a sector, take away the area of a triangle. So So the area of the sector, so we've got 56 degrees. So the fraction of the circle we've got is 56 360ths. So that's our fraction. And we've got that fraction of the entire circle, which is pi r squared. So the area of the sector is the area of the whole circle times by the fraction we have. 56 over 360 times pi times the radius squared, pi r squared. And I've got 70.37. I'll save that in the calculator. Centimeters squared. Now I need the area of a triangle. So we're going to use half AB sine C. We don't know the perpendicular height, so we use half AB sine C. So A and B are both 12, and C is 56. So it's half times 12 times 12 sine 56, half AB sine C, 59.69. Centimeters squared. And we just need to take these away now. So the area of the sector, take away the area of the triangle. So I saved the sector as A, take away the last answer, and I get 10.7. 70.37, take away 59.69 is 10.7 centimeters squared. Question 21. Work out the value of x, give your answer to one decimal place. So this is the sine rule and the cosine rule this time. And we want to know, so firstly, if we work out this middle one using the triangle on the right, and that would be the sine rule, then we can use the cosine rule to work out x for the triangle on the left. Let's start by finding this missing angle. So 180, take away 58, take away 67 is 55 degrees. And then we're going to use the sine rule, so it's opposites. I'll call this one y. So we've got these opposites, and we've got these opposites. I'm working out a length, so I'm going to put the lengths on top. So I'm going to have y over sine 55 equals 8 over sine 58. To get y by itself, multiply by sine 55. So I can just type that into the calculator. 8 over sine 58 times sine 55 is 7.727 and so on. Save it in the calculator or just use the answer button. 7.727. So now we know all three sides of the triangle on the left. We can use the cosine rule. We're not given this formula. This is the rearranged version. So cos A equals b squared plus c squared minus a squared over 2bc. So that's the rearranged version of the cosine rule that we use for finding an angle. So big A, little a, b and c. So it is cos x is 12 squared plus 11 squared minus our answer squared over 2 times 12 times 11. So 12 squared plus 11 squared minus answer squared over 2 times 12 times 11. 0.777. Shift cos the answer. 38.95 to one decimal place, it's going to be 39.0. Question 22. Solve. So we have algebraic fractions. Let's start by adding these two fractions together. To add fractions, we need the denominators to be the same. So I can make them the same. If I times the one on the left by x plus 3, so times top and bottom by x plus 3. And the fraction on the right times top and bottom by 1 minus 2x. So now the denominators are the same. We can add the two fractions together. We can make it into one fraction. And the numerator, if I expand, so it's 2 times 1, which is 2, and 2 times negative 2x, which is minus 4x. I want to get rid of the fraction, so I can multiply both sides by this denominator, which will get rid of it. I'll leave this numerator as it is for now, but I can collect those like terms. I'm going to have to expand these brackets at some point. So let's collect the like terms now. So 3 and 2 make 5. X take away 4x is minus 3x. And expand the brackets. 1 times x is x. 1, 3 is 3. Negative 2 times x is negative 2x squared. And negative 2x times 3, negative 6x. Now going to multiply through by 3. So I've got 3x plus 9 minus 6x squared minus 18x. I've got a quadratic. To solve it, I need to make it equal to 0. So I'm going to move everything over to the left side. So my x squared can be positive. So I've got 6x squareds. I've only got one x squared term. I've got minus 3x, minus another 3x, so minus 6x. But then plus 18x, minus 6 plus 18 is 12x. And I've got 5, take away 9, which is minus 4. I can make it simpler by halving everything. So I'll do that before I solve it. And I've got a quadratic I need to solve. We're in a calculator paper. It doesn't look like it factorizes. So we're going to use the quadratic formula. So A is 3. B is 6. C is negative 2. And the quadratic formula says x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to type it into the calculator. And we have to get two answers, one with the plus and one with the minus. So it's negative 6 plus or minus, so I'll do plus first, the square root of 6 squared minus 4ac all over 2a. So I've got 0.291 as my first answer. 3 significant figures. Of my second answer, I'm going to go back in and I'm going to change the plus into a minus. And I get negative 2.29. So they are my answers. Question 23. Prove algebraically that the straight line with equation 3x minus 2y plus 13 equals 0 is a tangent to the circle with equation x squared plus y squared equals 13. So if it's a tangent, whenever we have simultaneous equations on the graph, the answers are where they intersect. If it's a tangent, it has to have just one point of intersection. So we're solving these as simultaneous equations, and if there's just one answer, then it is a tangent. If there's one intersection, it's a tangent. So let's find out where the intersection is, and if there's only one of them, it must be a tangent. To solve these simultaneous equations, we need to get the linear one first and make it either x equals or y equals. And if I plus 2y to both sides, I'll get 2y equals 3x plus 13. And then half both sides, y equals 3x plus 13 over 2. So I'll have that is y equals. I can substitute it into my circle equation. So wherever I have y, I'm going to change it into 3x plus 13 over 2. So I've got x squared plus 3x plus 13 over 2 squared equals 13. I need to expand this. So squared means times itself. So it's 3x plus 13 times 3x plus 13. So times, when we times fractions, times the top and times the bottom. So it's going to be over 4 equals 13. I can get rid of the divide by 4 by timesing every term of my equation by 4. So I have 4x squared plus 3x plus 13 times 3x plus 13 equals 4 13s, which is 52. Now I need to expand these brackets. So 3x times 3x is 9x squared. 3x times 13 will be 39x. 13 times 3x is also 39x. And 13 13s will be 169. Collect the like terms. I've got 4x squareds and 9x squareds. So I've got 13x squareds. I've got 39 and 39. So that makes 78 x's. And I've got 169, take away 52, which will be 117. So it looks complicated, but we can simplify this. All of these are in the 13 times table. We know they are because we got all these numbers by multiplying by 13 in the first place. So 78 over 13 is 6, and 117 over 13 is 9. So if I divide through by 13, I've got x squared plus 6x plus 9 equals 0. And this factorizes. It's x plus 3 times x plus 3. And so there's only one answer. X is negative 3. So there's only one answer, only one intersection. Therefore, it's a tangent. We could go on and find out what the y coordinate is. We weren't actually asked to do it, but we just have to substitute negative 3 into our linear equation, and that will tell us the y coordinate of the point where the line touches the circle. But we've only got one answer, so that means it is a tangent. Question 24. The displacement of an object S is given by the formula S equals v squared minus u squared over 2a, where v is 15.49 to 2 decimal places, u is 4.92 to 3 significant figures, and a is 7.5 to 2 significant figures. By considering bounds, work out the value of S to a suitable degree of accuracy, show you're working clearly, and give a reason for your answer. So we're going to need to know the upper and lower bound for each of these. So 15.49 to 2 decimal places. So the lowest thing it could have been is 15.485. And the highest is 15.495. For 4.92 to 3 significant figures, 4.915 to 4.925, and the 7.5 is 7.45 to 7.55. So we need to work out the upper bound and the lower bound for S. So the upper bound for S, so we want to get the upper bound for S, we want the biggest possible V value, 15.495 squared. So to get the biggest possible answer, we want to take away the smallest number. So to get a bigger answer, you want to take away the smaller version. So that's 4.915 squared. And again, divide by the smallest possible answer. So if you want the biggest possible answer, you want to divide by a smaller number. Dividing by a smaller number gives you a bigger answer than dividing by a bigger number. So divide by the smallest number. And just type that into the calculator. Say 15.495 squared. Take away 4.915 squared over 2 times 7.45 squared. No, not squared. 2 times 7.45. So we get 14.49. 14.49. I probably don't need the rest of the figures, but I'll give them anyway. 24698. And the lower bound for S, so we want the other ones. So the smallest possible one to start, 15.485. Take away the biggest possible U squared. Take away 4.925 squared over 2 times the biggest possible A, 7.55. So go into the calculator, change D, so 7.55. This one is 4.925. And we've got 15.485. So we get 14.2734 and so on. So to a suitable degree of accuracy, what does the upper bound and the lower bound round to? We can say it is 14 to 2 significant figures, or the nearest whole number, as the upper bound and lower bound round to 14 to 2 significant figures. So the upper bound and the lower bound round to the same number. So that's the most accurate we can give it. If we went to 3 significant figures, we'll have 14.5 and 14.3. So they don't agree. So 14 to 2 significant figures, they both agree.